In this video, we're going to talk about cylindrical coordinates. So let's go back to our rectangular coordinates, x, y, z. These are sometimes also called Cartesian coordinates. And today we're going to be looking at a different coordinate system in 3D called cylindrical coordinates. So we use coordinates r, theta, and z for cylindrical coordinates. The r and theta are the same r and theta as we would use in polar, and it's the same z as we have in rectangular coordinates. So let's see if we can draw a picture of our cylindrical coordinates in 3D. So let's say we have a point right here, x, y, z, that we want to express in cylindrical. We'd say, okay, well, z coordinate is going to be the same as we would use in rectangular. And to figure out the r and the theta, we're just going to drop this point straight down into the xy plane, and then we're going to think about r and theta the same way we would with the 2D polar coordinates. So we would say r is the distance in the xy plane from the origin to our point, and we would say that theta is the angle going from the positive x-axis and going around counterclockwise to the positive y-axis. So theta is going in that direction there. So let's focus in on the xy plane here. And let's imagine that we had a point xy. Let's think about the coordinates r and theta with respect to that point. So r is distance in 2D between the origin and the point. Here's our angle theta, and let's say these are our x and y coordinates. So just from looking at this right triangle here, we should be able to deduce a few relationships between our variables. X is going to be r cos theta. So we know that from our discussion of polar coordinates. Y is equal to r sine theta. R is equal to the length of the hypotenuse, so r is equal to root x squared plus y squared. And if we wanted theta, we would say theta is arctan of y over x, but we may possibly have to correct this angle if it ends up being in quadrant 2 or quadrant 3. So I like to just say plus pi question mark, and we'll do an example in a moment to see what it looks like when we correct the quadrant of that angle. So these are the different relationships between x, y, and our theta that we may need if we're converting between rectangular and cylindrical. Let's convert the point xyz equal -4, 4, 5 into cylindrical coordinates. So easiest thing is to just observe the z value. That's not going to be changing. So z is 5. And then from there, we need to get r and theta. So r going to be the square root of x squared plus y squared. So that's going to be root 32, or you could call that 4 root 2 if you like. And then let's talk about theta in a bit more detail. So theta is going to be arctan of y over x. Okay, so if we take our y value and divide by our x value, that's 4 over -4, in other words, -1. But we may need to add pi to this. So let's draw a picture and understand why we need to have this plus pi question mark on here. Okay, well, we're interested just in the x and y value at this point. So I'm just going to draw our xy plane. And let's think about where -4 is located. So that's sitting over here in quadrant 2. So we're trying to describe this angle here. So there's our theta. When you put a value into arctan, arctan is returning to you an angle somewhere between -pi/2 and pi/2. So the arctan function is just not able to give angles in quadrant 2 or quadrant 3. So the way I think of it is if our angle ends up being on the left side of this diagram, either in quadrant 2 or quadrant 3, that's where we need to add pi to get the correct angle. So we can see from our diagram, because we are in quadrant 2, we do need to add pi. Arctan of -1 is going to be -pi/4. We're going to add pi to that to get 3 pi/4. Okay, and there we have all the information we need to write our point in cylindrical. So we typically write the order r, theta, z. And so our new set of coordinates in cylindrical, 4 root 2, 3 pi/4, and 5. So that's our intro to cylindrical coordinates. Thanks for watching.